Hey environmental science students, this is a skill to practice identifying plate boundaries while doing some calculations with metric conversions. You definitely want to be familiar with maps like this one that show tectonic plate boundaries and how to read them. The places where the arrows are converging towards each other are convergent boundaries. The places where the arrows are diverging away from each other are divergent boundaries. And if two plates are moving past each other, it is a transform boundary. Plates are moving at different speeds. That's why the size of the arrows represents. So you can see these really big ones. This would represent some that are going as fast as 10 centimeters per year, and some are as slow as 1 centimeter per year if you find some of the really small arrows. This is the same range as how fast your fingernails grow. So it's something that you can't see happening, but you can definitely notice over time. You can notice a change. You'll also want to be familiar with doing some conversions in the metric system, so we'll practice that. I have this little chart that might help you in the lesson section of the metric conversions. So let's try one together. A tectonic plate is moving north at a rate of 0.026 meters per year alongside another plate moving south. Once you read the part that says which way the plates are moving, you can try to answer this question. So this would be a transform boundary. And then first you want to notice that the choices for units are in meters and meters per year. So you have to do some conversions to get them to the right units. So we're given here that the rate is 0.026 meters per year. So that one was already in the units that we want. But then we have a distance of 1.8 kilometers. So let's show the conversion for how we would do that. So we have our 1.8 kilometers, and then we're going to convert that into meters. There we go. So we have 1 kilometer on the bottom and 1,000 meters on the top. Not my best work. Okay, trying a different thing here. So if we calculated that out, we would end up getting the distance here is 1,800 meters. I know it's an extra step to show the conversion there instead of just looking it up, but you'd want to be able to practice that for a test or the AP exam. All right, so now we want to know how long that will take. So you would do the calculation to show that. And you can do a distance equals rate times time formula and rearrange it, but it's also a good time to practice unit analysis. So you want to think about the units that you want. If we're looking for years, we want to get years on the top. And we have our 1,800 meters. There we go. Okay, so our 1,800 meters. And then we want to cancel out meters, so we're going to put it on the bottom. So I'll put our rate next to it, 0.026. Oh gosh. Meters on the bottom and 1 year on top before that disappears. Okay. So if we did that, we would end up getting 69,200. And then that would be years. Okay, let's try one more. So this one says a tectonic plate is moving beneath another plate at a rate of 1.8 centimeters per year. How far will it have traveled over the course of 4 centuries? So if one plate is going underneath another plate, that's a type of convergent boundary, and so we'll choose convergent. We're given that there's 4 centuries, so you would do 4 times 100 to get a time of 400 years. And we're given that the rate is 1.8 centimeters per year, but we need to change that into meters per year. So let's do that. We have 1.8 centimeters, 1.8 centimeters per year. And then we just want to change the centimeters into meters. So if I know that there's 100 centimeters in 1 meter, I'll put the centimeters on the bottom so that they cancel out. And then 1 meter on the top. So that way the centimeters cancel out, and then I'll end up getting 0.0 This was our rate, 0.018 meters per year. Okay, let's check our answers so far. And then our distance. So we could know that the distance equals rate times time, or have that formula. But if you didn't have that formula, you would want to be able to set it up with the unit analysis. So if I am looking for meters, I want my meters on the top, 0.018. And that's in meters per year. And then I want the years to cancel out. So I will multiply that by 400 years. Okay, so the years cancel out, and I would end up getting 7.2 as my answer. So 7.2, and then the answer is in meters. As you try these problems, if you aren't sure where to start, try to use those strategies to set them up. Think about what your units are going to cancel out to give you the units that you want. I hope that helps.